Students, now I am going to discuss about two methods. One is Euler's method and another one is modified Euler method. Here also, as usual, like our previous method, Taylor's, Picard's, they'll give us a first order first degree ordinary differential equation. Let dy by dx equals to f of x comma y be a first order first degree differential equation, and a condition they are giving. That condition is called subjected to condition. Subject to condition that what is that condition? As usual, like our previous method, y of x not equals to y naught. Okay, these are the things they are giving to us, but now we need to find that y1, y2, y3 and so on, like our Taylor's and Picard's is a different. Okay, so by using here by using Euler's method, we are going to find y1. What is y1? Y1 is nothing but y of x1. Okay, so and same manner we are going to find y2. What is y2? Y of x2. We are going to find y3. What is y3? Y of x3. So these are the things we are going to find by using Euler's method. But when it comes to Taylor's method, y1 is equals to y naught plus h into y naught dash plus h square by factorial into y naught double dash plus h cube by factorial 3 into y naught triple dash and so on. There is a lengthy thing. So, but same manner y2 and y3 formulas. But here y1, y2, y3 formulas are very simple. The formula of y1 is simply y naught plus h into f of x naught comma y naught in the function x and y, in the function f of x comma y. In place of x and y, we have to substitute x naught and y naught. This is the formula of y1. The same manner y2 is equals to y1 plus h into f of x1 comma y1. So same manner y3 formula. Y3 formula is depends upon x2 and y2. y2 plus h into f of x2 comma y2. So this is a formula of these are the formulas of Euler's method for finding y1, y2, y3 and so on. In the same manner, if we continue, I'm going to take a yn plus 1, yn plus 1, which is what is yn plus 1? Y of x1, xn plus 1. So what is a y1 depends upon y0 and x0. y2 depends upon y1 and x1. Same manner, yn plus 1 will be depends upon xn and yn. Then it will become yn plus h into f of xn comma yn. So these are the formulas of our Euler's method. Now going to discuss a problem on Euler's method. Just I'll discuss a problem. Solve y dash equals to x plus y, given that y of 0 equals to 1. Y of 0 equals to 1. Then find, so solve this by using Euler's method. And then find y of 0.3, given step size is 0.1. So they are providing here step size is 0.1. 0.1 is nothing but h is equals to 0.1 they given to us indirectly. So starting the solution, what is the given differential equation? Given dE is y dash equals to x plus y. Taking this as equation number 1, but Here, what is the general form of a differential equation? So with that general differential equation, we have to compare this differential equation. Compare equation number 1 with the dy by dx equals to f of x comma y. F of x comma y. So with this, what we can conclude? That implies f of x comma y equals to, what is f of x comma y? X plus y. X plus y. Now we got f of x comma y function, and also what they provided in the problem, they given the initial condition is y of 0 is equals to 1. So this one we have to compare with y of x naught is equals to y naught. With this, what we can conclude? X naught equals to 0 and y naught equals to 1. These are the values they provided to us in the given problem. Okay, now what we need to find? Y of x3, y of 0.3. Y of 0.3 is nothing but what? So what we need to find here? Y of 0.3. For finding y of 0.3, given step size is 0.1. Okay, so given step size, what is the step size? Is h equals to 0.1. So if we have h value, then what are the things we can find? We can find x1. What is x1? X naught plus h is 0.1. What is x2? 0.1. X1 plus h. X1 is 0.1, h is 0.1. So finally we'll get 0.2. X2 equals to. What is x3? X2 plus h. X2 value is 0.2, h is 0.1. So we'll get 0.3. Then what are the things we need to find? Actually, they asked us to find here. What we need to find? Y3, nothing but y of 0.3 value we need to find. For finding y3, according to our Euler's method, it depends upon x2 and y2. So we require to find y2 also. And for finding y2, it should be depends upon x1 and y1. So we need to find y1 also. So here, these are the values we need to find: y1, y2, and y3. Okay, so I'm marking with the question mark. That means we need to find y3 only, nothing but y of 0.3 only. But still, we need to find y1 and y2. They did not mention in the problem, but still we need to find y1, y2 also. So by using Euler's method, what is the y1 formula? Y1 equals to y naught plus h into f of x naught comma y naught. So substituting here y naught and x naught values, so we'll get x naught is equals to, sorry, y naught is 1 plus h is 0.1 into f of x naught comma y naught. How we can write f of x naught comma y naught as? F of x naught comma y naught as x naught plus y naught. X naught plus y naught. Here also we have to substitute it. 1 plus 0.1 into x naught is 0, y naught is 1. So finally we'll get 1 plus 0.1 into 1 is 0.1. So finally we'll get 1.1 is the value of y1. So what is the value of x? X1? X1 is equals to 0.1. So these are the values are required for us for finding the next y2. So what is the formula of y2? Step 2. Actually, it is a step 1 finished. Step 2. What is the step 2? Y2 formula. Y2 is equals to y1 plus h into f of x1 comma y1, which is equals to, here we have to substitute all the values of x0, x1, y1 and h value. So before we are going to substitute it, y1 plus h into, what is f of x1, what is f of x comma y? F of x comma y is x plus y. But in place of x and y, what we have to substitute? X1 and y1. So here substituting the values of y1 and x1. Y1 value is 1.1 plus h value is 0.1, which is the step size, into x1 is 0.1 plus y1 is 1.1. So we'll get here 1.1 plus 0.1 into 1 0.1 plus 1.1 is 1.2. If we multiply 1.2 with 0.1, what is going to become 0.12 plus 1.1. So if we add both, we'll get 1.22, which is our y2 value. But what is x2 value? We know that x1 plus h, that is 0.2. Okay, so we require these values for finding our next step. What is the next step? Finding y3. y3 equals to, what is the formula of y3? y2 plus h into f of x2 comma y2. Now y2 plus h into, how we are going to write f of x comma y? What is f of x comma y? X plus y. But in place of x and y, what we have to substitute for finding y3? X2 and y2. So substituting the values of x2 and y2. y2 value is 1.22 plus h is 0.1 into x2 is 0.2 plus y2 is 1.22. So by simplifying this, 1.22 plus 0.1 into 1.42. So if we multiply this 1.42 with the 0.1, we are going to get 0.142 plus our y2 value is 1.22. So finally we'll get a 1.362 is the value of y3. Okay, so this is the required value. Therefore, hence y of 0.3, y3 is nothing but y of x3, x3 is nothing but 0.3. Y of 0.3 is equals to 1.362. So this is our value which they asked us. Okay, so same manner, I'm giving you for your practice a problem for your practice. Sometimes they will ask, compare the solution of y of 0.3 value with the analytical solution. What we have to do, analytical solution is nothing but we have to do again the same process of ordinary differential equations and all. And after completion of that, we need to compare these values with the analytical solution values. Okay, so like that, there may be a chance they may ask like that. Okay, so next problem is solve y dash equals to x square minus y, and they are providing one more condition, y of 0 is equals to 1. Then find, okay, solve this by using Euler's method. Okay, and then find y of 0.2, y of 0.4, y of 0.6, and y of 0.8. So they may give more also, more number of values also. Okay, find these values. This is I'm leaving for your practice purpose. Okay, so next I'm going to discuss about next method is modified Euler's method. What is a modified Euler's method? The modified Euler's method is little bit changes are there compared with the Euler's method. So I'm just copying as it is, like what we taken in our Euler's method. So what we have taken in the Euler's method, same steps. Let dy by dx equals to f of x comma y. Let dy by dx equals to f of x comma y, and all I'll take the same as it is. But here I'm taking subject to the condition, and also I'm taking using Euler's method first step also. I'm taking as it is. but small change will be there. The change I'm going to discuss in modified Euler's method. So we are going to get here the same as it is. Let dy by dx equals to f of x comma y, and subject to the condition that y of x not equals to y naught. But here we need to use, we are going to learn the modified Euler's method. Here I will change here, like instead of using Euler's method, what is this thing we have to take? Modified Euler's method. By using modified Euler's method, what we did in our Euler's method, simply y1 is equals to y naught plus h into f of x naught comma y naught. But here in a single step we are finding y1 value. But in modified Euler's method, what we did in our Picard's method, finding the first approximation of y1, second approximation, sorry, finding the first approximation of y, finding the second approximation of y, finding the third approximation of y, like that. After continuing so many number of approximations, like 3 or 4 approximations, we are finalizing the y function in terms of x variables. In the same manner, we need to find the first approximation of y1, second approximation of y1, third approximation of y1, fourth approximation of y1, and so on, like that. After few approximations, it may be 3 or 4 approximations, we have to stop the approximate value of y1, and we need to finalize that is our y1 value. Okay, so here first I'm going to take a 0th approximation of y1. Okay, so what I am taking, 0th. So here, first I'm going to find 0th approximation of y1. How we can denote 0th approximation of y1? In power of y1, we have to mention 0. First, okay, 0th approximation of y1 is, as usual, like Euler's method, y naught plus h into f of x naught comma y naught. This is the first formula. And then going to take a first approximation of y1. The first approximation of y1 will be like this. Y1 in the power, we will get in brackets 1 is equals to, here we have to add the same y naught plus, I'm going to take a same our f of x naught comma y naught, and I'm going to take one more, which is f of x1 comma 0th approximation of y1. 0th approximation of y1. We have to add both and multiply it with, actually it is, we have to multiply with h, but take the average of these two, nothing but h by 2. This is the first approximation of y1. So what is the first approximation of y1? Y1 power 1 in brackets is equals to y naught plus h into, no, sorry, h by 2 into f of x naught comma y naught plus f of x1 comma 0th approximation of y1. So same manner, we have to take a second approximation of y1, finding the same y1, but the second approximation of y1 is, so how we have to write the second approximation of y1 power 2 is in brackets is equals to same thing, y naught plus h by 2 into f of x naught comma y naught plus, sorry, f of x naught comma y naught plus f of what we have to take, x1 comma first approximation of y1 we have to take. What is the latest approximation of y1? First approximation of y1, that we have to take. So same manner, we have to go for third approximation. So we have to go for third approximation. In the same manner, we have to go like this, and we have to go up to kth approximation or k plus 1th approximation. So I'm writing here, similarly, in general, k plus 1th approximation of y1 is, k plus 1th approximation of y1 is, what is the k plus 1th approximation of y1? y1 power, we have to denote k plus 1 in brackets is equals to, what is that? Y naught plus h by 2 into same thing, f of x naught comma y naught comma, sorry, plus f of x naught comma y naught plus f of what we have to take, x1 comma, what is the latest approximation of y1? Now we are finding the k plus 1th approximation. What is the previous approximation of k plus 1th? Okay, y1 is kth approximation. So kth approximation of y1, we'll get it. So this is the general formula of y1. So like this, how many number of approximations we have to take? So until we can go with 2 or 3 or 4 approximations, and you can stop it. Okay, so this is called as a step 1. Step 1 is finding y1. Now going to take a step 2. What is the step 2? Finding y2. Step 2. Step 2 is finding y2. For finding y2, what we have to do? First, we have to go with the Euler's method. So we have to go with the 0th approximation of y2. I'm not writing here all these things. So simply I'm mentioning 0th approximation of y2 is, what is the Euler's formula? y1 plus h into f of x1 comma y1. Okay, so same manner, what is the first approximation of y2? Is equals to y1 plus what we have to get? H by 2 into f of x1 comma y1 plus f of x1 comma y1 plus f of x2 comma 0th approximation of y2. What is the latest approximation of y2? 0th approximation. That we will get it. So this is the formula for y2, or first approximation of y2. Same manner, what is the second approximation of y2? Second approximation of y2 is y1 plus h by 2 into f of x1 comma y1 plus f of x2 comma, what is the latest approximation of y2? First approximation of y2. So this one. So like this we have to continue. Okay, so this is for finding y2. Okay, how many approximations we have to take? Until the successive approximations are nearly equal, but generally it is enough to do with 2 or 3 approximations of y1, y2, y3, like that. So similarly, what is the step 3? What is the step 3? Finding y3. What is the y3? Same manner, I'm going a little bit fast. Finding y3. So what is the formula of y3 using Euler's method? Using Euler's method, y3 equals to y2 plus h into f of x2 comma y2. Okay, so next this is the 0th approximation of y3. Now we need to find the first approximation of y3. First approximation of y3 is y2 plus what we'll get? H by 2 into f of x2 comma y2 plus f of x3 comma 0th approximation of y3. Latest approximation of y3 is 0th approximation of y3. So next, same manner, we have to go for second approximation of y3. What is the second approximation of y3? y2 plus h by 2 into f of x2 comma y2 plus f of x3 comma latest approximation of y3 is first approximation. That we have to substitute in place of y. Okay, so like this we can continue the same procedure, continue the same process to find what are the things? y4, y5 and so on, y6 and so on. So like yn also. Okay, so these are the things. Now going to explain is problem. Only 1 or 2 steps I'll take, not more than that. So here they're asking that using Euler's method, okay, sorry, solve y dash equals to y plus e power x by, okay, and they are providing us a initial condition also, y of 0 is equals to 0. Which method they are mentioning is solve this differential equation by using modified Euler's method. Modified Euler's method. Find by using this modified Euler's method, we need to solve that. And also, they're asking us to find y of 0.2 and y of 0.4. That means we need to find y1 and y2, what they provided indirectly, x values, x1 is equals to 0.2 and x2 equals to 0.4. Then what is the value of h? H is 0.2. Okay, so starting our solution, given dE. What is the given differential equation? Y dash equals to y plus e power x. I think this is equation number 1, but they given one more condition, y of 0 is equals to 0. Okay, so with which one we have to compare this differential equation? We have to compare it with dy by dx equals to f of x comma y. F of x comma y. Then what we can identify that f of x comma y equals to y plus e power x. So this is very important for us. You can take as equation number 2 if you require. Okay, I'm taking as equation number 2. And they given y of 0 is equals to 0, nothing but y of x not equals to y naught. With this, we can write x not equals to 0 and also y not equals to 0. So they given this value. Now what we need to find? We need to find y of 0.1 and y of y of 0.2 and y of 0.4. Nothing but take x1 is equals to 0.2. Now we need to find y1. Nothing but y of 0.2. Same manner, x2 is take x2 as 0.4. That implies we need to find y2. Y2 is equals to how much? That means y of 0.4 we need to find. So with this, what we can conclude, x1 we got, x2 we got, and we need to find y1 and y2 values. But here, if we observe the values of x, all the x values will be successively, okay, equally spaced. Okay, clearly what we can say here, clearly h equals to, that is a step size, h is equals to 0.2. Okay, now going to do for finding y1. So what we have to take step 1. What is the step 1? First I'm writing the formulas. Finding y1. Finding y1. Okay, so for finding y1, first what are the things we have to use here? Zeroth approximation. What is the zeroth approximation of y1? Zeroth approximation of y1 formula is y naught plus h into f of x naught comma y naught. Okay, then we need to find first approximation of y1. What is the first approximation of y1? First approximation of y1 formula is y naught plus h by 2 into f of x naught comma y naught plus f of x1 comma zeroth approximation of y1. Zeroth approximation of y1. So same manner, I'm going to write one more approximation. What is the second approximation of y1? Second approximation of y1 formula is same manner, y naught plus h by 2 into f of x naught comma y naught plus f of x1 comma, what is the latest approximation of y1? First approximation of y1. This is the thing I am writing. Okay, now going to find our zeroth approximation of y1. What is the formula of f of x comma y? So here I am writing y naught plus h into f of x comma y is y plus e power x. What is in place of x and y we have in the function x naught y naught. So writing the formula also in terms of x naught and y naught. So it will become f of x naught comma y naught will become as y naught plus e power x naught. How I am getting? In equation number 2, I am substituting in place of x and y, x naught and y naught. So now substitute the values of y naught and x naught and h values. Okay, y naught is 0 plus h value is 0.2. So h naught is 0.2, and then y naught value is 0 plus e power x naught value is 0. So 0 plus 0.2 into y naught value is 0 plus e power 0 is nothing but 1. So what we'll get finally, first term is 0. Okay, so 0.2 into 0 plus 1 is 0. So finally what we are going to get, our answer will be 0.2 we'll get. So this is the value of 0th approximation of y1. So what is the 0th approximation of y1 value we got, which is 0.2. And what is x1? X1 is equals to 0.2 we have taken here. So check here on the top right side, x1 is equals to 0.2. Okay, so now we need to find our next values. So before going to find next values, everything write down in the form of x naught y naught always. So h by 2 into what is f of x comma y? F of x comma y is y plus e power x, but in place of x and y we are having x naught and y naught. Okay, this is the thing. Plus, what is the second term? What is the second term? F of x1 comma 0th approximation of y1. But here, use the same formula. F of x comma y equals to y plus e power x. E power x. But in place of y, what we have here? 0th approximation of y1. And also first plus in place of x we are having x1. So substitute all these values. Substituting all these values, y naught value is 0 plus h value is 0.2 by 2 into y naught value is 0 plus e power x naught value is also 0 plus second term, 0th approximation of y1 is 0.2 plus x1 value is 0.2. Okay, so this is the thing. Now we need to find this value. So use the calculator and find out the value. So writing some more simplification here. 0 plus anything is 0 only. Okay, that value only. So 0 I am not considering. 0.2 by 2 is 0.1 into. The first term become e power 0 is 1. 0 plus 1 plus 0.2 into 0.2 plus e power 0.2. So use your calculator and find out the value. Then getting the first approximation of y1 is, the first approximation of y1 value will be 0.24 214. Okay, so you can take up to 4 decimal places or 5 decimal places. Same manner, we need to go for finding second approximation of y1. Second approximation of y1. Okay, so for finding second approximation of y1, substituting all the values again here. So y naught value is okay, writing in the form of like this only, y naught plus h by 2 into f of x comma y is y plus e power x. But in place of x and y we are having x naught. So we have to substitute in place of x and y, x naught and y naught, plus f of x comma y is equals to y plus e power x. But in place of x and y, what we have in our function? In place of x, we are having x1. In place of y, we are having first approximation of y1. So first approximation of y1. So substitute the values of all the things here. y0 is equals to 0 plus h value is 0.2 by 2 into y0 value is 0 plus e power x value is 0, x0 value is 0 plus first approximation of y1 is 0.24214. You can take up to 4 decimal places, no problem at all, plus e power 0.24214, but here I am taking 5 decimal places. Okay, so same manner, if we do simplification, first term is 0, 0.2 by 2 is 0.1 into 0 plus e power 0 is 1 plus, okay, we'll get like this 0.24214 plus e power 0.24214. So if we do the calculation of this, we'll get the second approximation of y1 value is something like 0.2463. Okay, so if you want, you can go for third approximation also. Okay, better, I'll go for third approximation. Third approximation, what is the third approximation formula? Third approximation of y1 is equals to, the formula is y0 plus h by 2 into f of x0 comma y0 plus f of x1 comma second approximation of y1. Second approximation of y1 is equals to, substitute all the values, y0 plus h by 2 into, okay, better, what we are doing here. So for making our calculations, or the thing is simple, what we are finding here, f of x0 comma y0 value. So you can observe here, we are finding f of x0 comma y0 value. Okay, so how much we are getting, this value is 1, simply. So same thing we are finding here also, f of x0 comma y0, no change at all. So what will get it? It is also 1 only. So I can substitute directly 1 here instead of substituting everything. So I'm writing with a different color, 1 plus. So what we'll get, the next term. Next term will be using f of x comma y. Formula is y plus e power x. Okay, in place of x substituting x1, in place of y substituting second approximation of y1. These are the things. Substitute all the values. Y0 value is 0 plus h value is 0.2 by 2 into 1 plus second approximation of y1 is 0.2468 plus e power 0.24, sorry, 63. It is only 3, not 68, not 68, it is 63. So if we do simplification of this, if we do the simplification of this, then we are going to get the third approximation of y1. Third approximation of y1 value will be, use a calculator and find out. So getting like 0.2468. What we got in the second approximation of y1 value, 0.2463. But what is the third approximation of y1? We got 0.2468. So only the fourth decimal place is different. So hence I'm assuming, hence approximate value of y1 is, approximated value of y1 is, y1 equals to, this value I'm going to finalize as y1. So what is our next case? Finding step 2, y2. Step 2. What is the step 2? Finding y2. So I'm leaving this concept finding y2 for your reference. You people do it. What is the y2? Just I'll write in a minute the formulas. So here, what are the formulas we have to take? Y2 is equals to y1 plus h into f of x1 comma y1. This is the basic formula of Euler's method. But here we have to take a zeroth approximation of y2. But next, after finding zeroth approximation of y2, what we need to find? We need to find the first approximation of y2. What is the first approximation of y2? y1 plus h by 2 into f of x1 comma y1 plus f of x2 comma first zeroth approximation of y2. So we have to go like this, second approximation of y2, third approximation of y2, like that. So up to what extent we have to continue like this? Whenever the successive approximations of y2 values are nearly equal, then you can stop, and that is our final value. So do this one. I am leaving this step 2 for your practice. Okay.
Solve dy by dx equals to 3x square plus 1, and given that y of 1 equals to 2, solve this one by using Euler's method. Euler's method. Okay, so after this, then find y at x equals to 2. X equals to 2. First case. Otherwise, given step size, first point is h equals to 0.5, and the second point is h equals to 0.25. Okay, so I'm going to explain for h equals to 0.25. Now, solution. The solution will be, what is the given differential equation? Solution, given dE is dy by dx is equals to 3x square plus 1. Take it as equation number 1, and also provided y of 1 equals to 2. Okay, so also what they provided, given h equals to, second condition I am explaining, h equals to 0.2. So what you have to do, h equals to 0.5, you have to do 0.25 h equals to. So now what we have to do, compare this differential equation with what is the general form of first order first degree differential equation? Compare with dy by dx plus f of x equals f of x comma y. Sorry, dy by dx equals to f of x comma y. Okay, so now if we observe this by comparing these two, what we can understand, what is f of x comma y? F of x comma y equals to 3x square plus 1. So putting this in the box, and they provided a h equals to 0.25. This is also important for us. And from this point, what we can understand, what they given indirectly, y of x naught equals to y naught. What is x naught value? Is 1, and y naught value is 2. Now, which value we need to find? Y value at x equals to 2. For finding y value at x equals to 2, we have to take x naught is equals to 1 to up to 2. How we can take? By taking the step size, x1 is equals to, what is the formula of x1? x naught plus h. What is x naught value? Is 1, h is 0.25. So x1 is equals to 1.25. That implies, what is the y1 value? We don't know. We need to find. Next, x2. What is x2 value? x1 plus h. x1 is 1.25 plus h value 0.25 is 1.5. Then we need to find y2. Same manner, x3. x3 is equals to x2 plus h. So how much will it become? 1.75. Now we need to find y3. After finding x3, finding y3. Next, x4. What is x4? x3 plus h is 2. So we need to find y4. That means we need to find y1, y2, y3, y4. So we got finally x value is 4. Then the corresponding y value we require to find. But they are asking this y4 only. They're not asking the remaining 3 values. But is it we required to find all the remaining 3 also? Yes, it is mandatory need to find. Because without y1, we cannot find y2. Without y2, we cannot find y3. Without y3, we cannot find y4. So all these 4 values we need to find. Indirectly, they are asking that. Okay. So taking by using Euler's method, by using Euler's method. 1 second, students. By using Euler's method, what is the first step? Step 1, y1 is equals to y0 plus h into f of x naught comma y0. But here y0 plus h into what is f of x comma y? F of x comma y is 3x square plus 1. F of x comma y equation is 3x square plus 1. So I am writing same 3x square plus 1, but in place of x and y, what we have to substitute in the function? What is given? x0 and y0. So 3x0 square plus 1. So substituting the values, y1 is equals to y0 value is 2 plus h value is 0.25 into 3 into x1 value is sorry, x0 value is 1 square plus 1. So anybody can say what is the answer you are going to get? 2 plus 0.25 into 3 plus 1 is 4. Okay. So 2 plus 0.4 into 0.25 into 4 is 1. So 2 plus 1 is 3. y1 is equals to 3. And what is x1? Already we know that 1.25. 1.25. Now we need to take the second step. Step number 2. Step number 2 is y2 is equals to, what is the formula using Euler's method? y1 plus h into f of x1 comma y1. y1 plus h into, what is f of x comma y formula? 3x square plus 1. In place of x, we have to substitute x1. So x1 square. So what is the value of y1? y1 value is 3 plus h value is 0.25 into 3 into x1 value is 1.25 whole square. It is x1 square plus 1. So 3 plus 0.25. I think you people can use the calculator and can say what is the answer. Okay, good. 4.4219. One of your friend is saying 4.4219. Now, same manner, we need to find y3. What is the formula of y3? Using Euler's method, y2 plus h into f of x2 comma y2. y2 plus h into f of x2 comma y2 can be written as f of x comma y is 3x square plus 1. But here in place of x, what we have to substitute? X2. So 3x square plus 1. So substitute the values of x and y. y2 value is 4.4219 plus h is 0.25 into 3 into x2 value is 0.5. Sorry, 1.5. It is 1.5. 1.5 whole square plus 1. So what we are going to get y3 value? Y3 value is, okay, good. What is the y3 value? So meanwhile, y3 value is 6.3594. 3594. Okay, one of your friend mentioned it is as a y3. Now going to find y4. Why? We need to find up to y4. y4 is equals to y3 plus h into f of x3 comma y3. F of x3 comma y3 is equals to y3 value is, okay, I am writing y3 plus h into, what is f of x3 comma y3? Writing it is as 3x3 square plus 1. Okay, now substituting all the values of x3, y3 and h. Y3 value is 6.3594 plus h value is 0.25 into x3 value is 1.75. It is a whole square plus 1. Good, Diana and Balaji. 8.9061 or 63 like that. 8.9061 I am taking. Okay, y4 value. So what is the y4 is nothing but, which is nothing but y of x4. y4 equals to y of x4. x4 value is 2. Y of 2 value is 8.9061. So completed finding our value by using case 2. What is the case 2 I mentioned as here? H equals to 0.25. Same manner, you people complete the problem with, here I am underlining, this is our H value we have taken, but they asked one more value also. You people complete the problem by taking H equals to 0. So they're asking a question like this: solve the differential equation dy by dx equals to x square plus y, and given that y of 0 equals to 1, by using modified Euler's method, find y of 0.02 and y of 0.04. So now solution. The solution is given differential equation is, what is the given differential equation? Dy by dx equals to x square plus y. Taking it as equation number 1 just for our understanding purpose. And what is the condition they giving to us? Y of 0 equals to 1. Now with which one we have to compare this equation 1? Compare with dy by dx equals to f of x comma y. It is better to write compare with dy by dx equals to f of x comma y. Why? The reason is, you will not here, if I am writing f of x comma y directly, then you may fail difficulty. But when you prepare, when you are practicing on preparing for the examinations, then how I got what is f of x comma y, that is important. And here they given y of 0 is 1, nothing but what they given indirectly, y of x not equals to y naught is provided. With this, what we can conclude, x not equals to 0 and y not equals to 1, but we need to find y of 0.02 and y of 0.04, nothing but here x, okay, we need to find y of 0.02 and also we need to find y of 0.04. It's nothing but we are going to take these are as y1 and y2. Y1 and y2 are nothing but that are the values of x1 and x2. What are the values of x1? 0.02. What is the value of x2? 0.04. So now we need to find our y1 value and y2 value. This is our question mark. But clearly what we can say with all the values of x, what we can say? Clearly we can say that what is the value of h? Clearly h equals to 0.02. This is the thing. But sometimes if they're asking the problem like this, they're not asking the question like this. They're asking us to find y of 0.02 and y of 0.06. then what you can understand? They're asking to find y of 0.02 and y of 0.06. అప్పుడు ఏమని అర్థం చేసుకుంటారు? What you can understand? Indirectly, they're asking us to find y of 0.06 also, but it is not required to find y2. But without finding y2, can we go for next value y3? No, we should not go. We should not go. Okay, so that is the reason. Don't get confused అవ్వకండి. ఓకేనా? సో ఎక్కడ కన్ఫ్యూజ్ అవ్వద్దు. 0.02 and 0.06 ఫైండ్ అవుట్ చేయమన్నప్పుడు మీరు కన్ఫ్యూజ్ అవ్వద్దు. యూ షుడ్ నాట్ గెట్ కన్ఫ్యూజన్. ఓకే, సో దిస్ జస్ట్ a trick while they are going to ask the questions. Now, which methods we have to use? By using modified Euler's method. Euler's method. We need to find y of 0, y1 is equals to y of 0.02 and y2 equals to y of 0.04. Okay, so going to take a step one. What is the step one? Finding y1. Just for understanding purpose, I'm taking like this side heading. It is not required to write like side heading. Finding y1. So first, going to find the 0th approximation of y1. 0th approximation of y1 is, what is the formula of y1? 0th approximation of y1, y0 plus h into f of x naught comma y0. But writing f of x comma y formula, y0 plus h into, what is f of x comma y formula? X square plus y. But in place of x and y, we have x naught and y naught in f of x comma y. Okay, so substituting all the values, y naught value is 1 plus h is 0.02 into x naught square, nothing but 0 square, plus y naught value is 1. So finally, we are going to get 1 plus 0.02 into 1. So finally, 0th approximation of y1 is 1.002. Now we need to go for finding first approximation of y1.
Sir,
Yes.
1.02 or 1.
Sorry. Yes, 1.02 only. Sorry. Thank you for correcting the value. So it is 1.02 only. So I thought, okay. So 1 plus 0.02 is 1.02 only. Then finding first approximation of y1. The first approximation of y1 formula is y0 plus h by 2 into y0 plus h by 2 into f of x naught comma y0. Yes, 552, anything you want to write, plus f of x1 comma 0th approximation of y1. Okay, so writing it in the form of variables only, y0 plus h by 2 into f of x naught comma y0. So what I'm going to do is, after finding this first approximation of y1, if you observe, the 0th approximation of y1 is 1.02, but first approximation of y1 is 1.020204. Nothing but the fourth decimal is only changing. There it is 0, here it is 2. So you can stop here if you want, or you want to go for one more approximation, you can go. So better go for second approximation also. Second approximation of y1 is second approximation of y1 equals to, what is the formula of second approximation of y1? Y0 plus h by 2 into f of x naught comma y0 plus f of x1 comma first approximation of y1. This is the thing. But here, okay, y0 plus h by 2 into, actually we need to write all time x naught square plus y naught like that. But observe carefully, what is a f of x naught comma y naught value we got here? We got f of x naught comma y naught value is writing like this. What is the value we got here? It is, this is how much we got here? It is 1 only. Same manner, if I am going for what is f of x naught comma y naught we got here also? Here also, this one same, 0 square plus 1 is 1 only we got. So I am going to use 1 directly from here onwards whenever we required zeroth approximation. Okay, we required f of x naught comma y naught. So substituting directly 1, no problem, you can substitute it. I'm putting some brackets plus f of x1 comma y1 can be written as x1 square plus y. Y is nothing but first approximation of y1. Okay, so substituting all the values of x and y, y0 is 1 plus h is 0.2 whole by 2 into 1 plus x1 value is, what's the value of x1? 0.02 whole square plus first approximation of y1, 1.020204. Just now we got it. Then 1 plus 0.01 into 1 plus 0.02 whole square is 0.0004 plus 1.020204. So doing simplification, 1 plus 0.01 into, actually you can do calculator, but I am not having calculator now, so I am doing manually. So 2.020604. Am I correct? So multiplying this with 0.01, then it will become 1 plus 0.02020604. So adding to 1, then it will become the first, second approximation of y1 is 1.02020604. This is the thing. Okay, next, if you observe carefully, the first approximation of y1 and second approximation of y1 up to 5 decimal places same, only 1 decimal place is different. What is that 1 decimal place? 6th decimal place. So why should we have to go for more number of approximations? So assume hence approximated value of y1 is, y1 is nothing but what we are finding? Y1, which is nothing but we have 0.02 is equals to 1.02020604. Okay, so got only y1. So same manner, what is our next procedure? Step 2. What is the step 2? Till now we got only y1. Step 2 is finding y2. So do the same procedure for finding y2. I hope you know how much time it is taking. Okay, so with this